Hi everyone, I am T. Ramesh, Assistant Professor, Department of Mathematics, Dr. SNS, Rajalakshmi College of Arts and Science. In this lecture series video, we are discussing about methods of dispersions. From this, we have the standard deviations and the coefficient of variation. So what is standard deviation? Standard deviations also called root mean square deviation. That is, standard deviation is the root square of mean of square deviations from the arithmetic mean, and it is denoted by the Greek letter sigma. So we calculate the standard deviation for individual series using the formula square root of sum of d square divided by n, where d is difference between average and the given data. Or the step deviation method is root of sum of d square by n minus sum of d by n the whole square, where d is x minus a is assumed mean. So standard deviation is a measures how dispersed from the data is relation to the mean. That means standard deviation is how many data are very clustered to its average. That is standard deviation. So the highly standard deviation shows that the data is widely spread or less reliable, and is low standard deviation show that its data are clustered closely around the mean. So that is the meaning of standard deviation. Now we take the problem. We calculate the standard deviation from the following data. So the data are 12, 22, 9, 15, 20, 17, 12 and 11. So now we calculate the standard deviation using the formula square root of sum of d square by n, where d is x minus x bar. So in this individual series, the average value is 15. That means sum of all the data divided by number of data. So we sum all the data and the number of data. There are 8 data are given. So the answer is sum of all the data divided by 8, that is equal to 15. So now we calculate the d and the d value. So first we write the x value. X value is the given data and the d is x minus x bar. So x bar is 15. So x is 14. So 14 minus 15 is minus 1. X value is 22 and x bar value is 15. So 22 minus 15 is 7. Now the x value is 9. X bar value is 6. And the difference of 9 and 15 is 6. And then x value is 15 and the d value is 15. So 15 minus 15, 0. And the x value is 20. X bar value is 15. So 20 minus 15 is 5. Likewise, we have another data. And then what is the d square? That just a square of d. So minus 1 square is 1. 7 square is 49. Minus 6 square is 36. 5 square is 25. 0 square is always 0. 2 square is 4. 3 square is 9. Minus 4 square is minus 16. And then what is the total? The total value is 140. So apply the formula. The standard deviation is root of 140 divided by number of data is 8. That is root of 17.5. That is equal to 4.18. Okay, next we have one more problem, the same as the shortcut or otherwise the step deviation method, how calculate the standard deviations. Apply the same formula, sum of d square divided by n minus sum of d by n the whole square, and taking the root, where d is x minus a is assumed mean. First we write the x value, the given data, we write all the data, and a is among all the data, we choose one value, any value we choose randomly. The assumed mean value is 20, that is called a. So d is x minus a, that is 14 minus a value is 20. So 14 minus 20 is minus 6. 22 minus 20 is 2. 9 minus 20 is minus 11. And likewise we have all the values of 20. Then we take square of the d. So minus 6 square is 36. 2 square is 4. Minus 11 square is 121. Likewise all the square value of d. Finally we take what is sum of square value, that is 140, and I apply all this formula. We get the standard deviation is 4.329. Okay, now we have another different problem. We calculate standard deviation for discrete series. The size of items are 6, 7, 8, 9, 10 and 12, The frequency 3, 6, 9, 13, 8, 5 and 4. We calculate the standard deviation is 1.6. Okay. So now we take another one. So the 6, 7, 8, 9, 10, 11 and 12, these are, the data are given, and the frequency is 3, 6, 9, 13, 8, 5, 4 something. And now we calculate fx. What is fx? Because we need what is the average value. So what is the average for discrete series? Sum of fx by sum of. So that purpose we need fx. So multiple f and dx, and then we take it is for total value of fx is 432 and the total frequency is 48. Therefore the average is 482 by 48, that is equal to 9. Therefore the fx value is 9. X bar value is 9. Now we take what is d. As usual, d is difference between the data and the average. That is 6 minus 9 is minus 3, 7 minus 9 is minus 2, 8 minus 9 is minus 1. Likewise, we take d value. And then square of d, we get 9410149. Then we need fd square. So fd square is square of multiple of f and d square. That is 3 9s are 27, 6 4s are 24. Likewise, we take all the value and the total fd square value is 124. Then substitute the standard deviation is square root of sum of fd square by sum of, that is square root of sum of fd square value is total value is 124 and the sum of value is 48, that is equal to 1.6. Next we calculate the standard deviation for continuous series for the given data. So the standard deviation is calculated from square root of sum of fd square by n minus sum fd by n the whole square into c. Now we consider the data, calculate the lifespan of the members and its neon light of its data. So the lifespan is 4 to 6 and the number of neon lights are 10 and the lifespans yes 6 to 8 categories, the number of neon lights are 17. Likewise all. Now we take the standard deviation using the formula square root of sum of fd square by n minus sum of fd by n the whole square into c. So here the sum, as usual, the previous value we calculate, we write the interval and the neon lights, number of neon lights, write that, and we calculate the mid value is calculated from the given interval, that is 4 plus 6 by 2 is equal to 5. Next interval 6 to 8, the mid value is 6 plus 8 is 14 by 2, that is equal to 7, and so on. 9, 11, 13 is the mid value. So we calculate d. D is x minus a by c, where a is assumed mean from the given mid value, and c is length of the class interval. So d minus a by c, that is d is now here d. What is d? X minus a by c. X is 10. A is, we assumed mean, we take any value. A is 9. So 10 minus or the mid value is something. So x is the mid value, a is 9. So 5 minus 9 divided by the length of the interval, that is 2. That is minus 4 by 2 is 2. Next 7 minus 9 is minus 2 divided by 2 is minus 1. 9 minus 9 is 0. 11 minus 9 is 2 divided by 2 is 1. 13 minus 9 is 4. 4 divided by 2 is 2. Next we take what is fd and fd square, so on. So we find all the values from the data and fit it in the formula, we get 2.352. Next, coefficient of variation. What is coefficient of variation? Coefficient of variation is the ratio proportions of standard deviations with respect to mean, or the percentage of. Coefficient of variation is the percentage variations of mean and its standard deviation. So that is so that the relationship between standard deviations and arithmetic mean expressed in terms of percentage. So this measures of coefficient of variations as the most commonly used measures of relative variations. If you want to compare the variety of 2 or more series, we can use this method. So if the coefficient of variation is greater, indicates that the group is more variable, less stable, or less uniform, or less consistent, or less homogeneous. If the coefficient of variation is less, indicates that the group is less variable, more stable, or more uniform, or more consistent, or more homogeneous. Now we consider the problem. In two factories, A and B, engage in the same industrial area. The average weekly wages and the standard deviations are given below. The factory A and B, the average wages in factory A is 34.5 and its standard deviation 5. The number of workers are 476. Similarly, another factory B, the average workers are 28.5 and its salary 28.5. Standard deviation is 4.5 and the number of workers are 524. Now, which factory A or B pay the out of larger amount is weekly wages? We calculate that. And the next one, which factory A or B has greater variability in individual wages? Now we take what is total wages paid by the factory A. So the average is 34.5 and the number of workers are 476. Multiple of these two, we get 16,422. Next, the total wages paid by factory B is the average is 28.5 and the number of workers are 524. Multiple of these two is rupees 14,934. Therefore, the factory A, among these two value, A factory wages are more than B. Therefore, the factory A pays out larger amount as weekly wages. Next, we calculate which factory A or B has greater variability in individual wages. So we apply the coefficient of variations in this case. Therefore, the coefficient of variations of A is standard deviations divided by average into 100. That is, standard deviation of factory A is 5 and its average value is 34.5 into 100, we get 14.49. Similarly, we calculate coefficient of variation of B, factory B is standard deviation is 4.5 and average is 28.5 into 100. So after reduce that, we get 15.79. Use among these two value, the coefficient of variation of A is less than the coefficient of variation of B. Therefore, the factory B is greater variability is individual, but it is consistent values. Coefficient of variations of A on factory A is less than that of B. Therefore, A has consistent, but B is greater variability. Right here, there are the two values are given from the Venn data. Right. So the goal scores of two teams A and B in the football sessions were given. The number of goals 0, 1, 2, 3, 4 and the team A and B are given. So by calculating the coefficient of variation in each case, find which team have considered more consistent. So we calculate, there are two teams A and B. Now we calculate the coefficient of variation of team A, that is equal to 123.6% and the coefficient of variation of B is 109%. Among these two values, which one is smaller? Team B and its coefficient of variation is smaller than team A. Therefore, team B has more consistent. Therefore, team B is more consistent in the performance. Thank you.